In this video, we will do several practice problems, all of which will require us to do u-substitution somewhere along the way. Number 46. Find an equation for the function f that has the given derivative and whose graph passes through the given point. Behold the chain of calculus. If you want to go from f to f prime, you take the derivative, because the derivative of f is f prime. But if you want to go from f prime back to f, you take the antiderivative. In other words, you integrate. The integral of f prime is f. In this case, we are given f prime, and we are looking for f. If you want to go from f prime to f, you integrate. So let's take the integral of both sides of this equation. On the left side, the antiderivative of f prime is immediately f of x. On the right side, we have to do some work to find the antiderivative of negative 2x square root of 8 minus x squared dx. Let's use u-substitution. Let's try letting u equal whatever is under the radical. So let's let u equal 8 minus x squared. In that case, u prime is going to equal negative 2x. Doing the substitution gives us this, but instead of dx, we write du over u prime. So du over negative 2x. But then we notice that the negative 2x in the denominator will cancel out the negative 2x that we already have. For a brief moment, we have this. But instead of the square root of u, let's write u to the 1/2 power. Now we can use the power rule of integration. Increasing this exponent by 1 gives us u to the 3/2 power. Next we divide by the new exponent, but dividing by 3/2 is the same as multiplying by 2/3. And don't forget the plus c. Substituting 8 minus x squared back in for u gives us this. But we need to find the function that passes through this point. So we need to use the point 2, 7 to find the value of c. When x is 2, y should be 7. So if we substitute 2 in for x, the solution should be 7. Here I have plugged in 2 for x, and I have 7 for the solution. 2 squared is 4, so this is 8 minus 4, which is 4. When you have a fractional exponent, it is in the form power over root. So the root is 2, also known as square root. And then we have a power of 3. So we have square root of 4, but then to the 3rd power. The square root of 4 is 2, and 2 to the 3rd power is 8. 2 times 8 is 16, so we end up with 16 thirds plus c is equal to 7. Subtracting 16/3 from both sides, we get c equals 7 minus 16/3. If we multiply 7 by 3/3, we get 21/3. 21 thirds minus 16 thirds is 5 thirds. So we found the value of c. But remember, f of x is equal to all of this plus c. So the final answer will be this same expression, but with 5 thirds instead of c. So this is the final answer. Number 50 is one of those rare u-substitution problems where everything doesn't quite cancel out. But we have ways to handle this situation, so pay attention very carefully and don't panic. Well, let's start off by letting u equal whatever is under the radical. So u will equal 2 minus x. In that case, u prime is equal to negative 1. You can see how this does not cancel out the x that's outside. It doesn't cancel out the x plus 1. If you do the u-substitution right here, you get this. Instead of dx, we write du over u prime. So that's du divided by -1. On the next step, we will put the -1 out in front of the radical. As we mentioned, the x plus 1 is not being canceled out. That's a little bit of a problem. So what do? This expression for u is so simple that we can rearrange this to solve for x very easily. If we add x to both sides and subtract u from both sides, we get x is equal to 2 minus u. Now we can replace x with 2 minus u right here. So on the next step, this x will be gone, and in its place will be 2 minus u. Now we have this. We do have some like terms here. 2 plus 1 is 3. Instead of the square root of u, I'm going to write u to the 1/2 power, because on the next step, I'm going to distribute u to the 1/2 power, and it will be easier to manipulate this way. Obviously, 3 times u to the 1/2 power is just 3u to the 1/2 power. U times u to the 1/2 power is u to the 1 times u to the 1/2 power, and we add these exponents. So that's u to the 3/2 power. So I will have 3u to the 1/2 power minus u to the 3/2 power. This is something we can integrate term by term. I'm going to bring down the 3 for a moment. Also, don't forget that we have a negative sign way out in the front. But we can use the power rule of integration and add 1 to this exponent, giving us u to the 3/2 power. Then we divide by the new exponent, but dividing by 3/2 is the same as multiplying by 2/3. Let's move on to the next term. So we have u. If we add 1 to this exponent, that's 5/2. And then if we divide by 5/2, it's the same as multiplying by 2/5. In the end, don't forget the plus c. These 3's are going to cancel each other out. This is the final answer. To get this, I substituted 2 minus x back in for u, and I also distributed the negative sign. That's why this minus became a plus. For number 54, we want to let u equal the stuff that is under this radical. But if u is equal to t plus 10, then u prime is only 1. That's definitely not going to cancel out this t. So we're going to have to use the same sort of technique that we used on the previous problem to get rid of the t. First, we do the substitution. So we get this, and instead of dt, we write du over u prime, but du over 1 is just du. And here we are stuck with this t. So what do? Well, this is a simple expression, so it is very easy to solve for t. Subtracting 10 from both sides, we get t is equal to u minus 10. So let's replace t with u minus 10. Also, I put u to the 1/3 power instead of the cube root of u. Now we can do the distributive property. When you do u to the 1/3 power times u, you do something like this in your head, and you get u to the 4/3 power. And then 10 times u to the 1/3 power is just 10 u to the 1/3 power. We can integrate this term by term. So let's bring down the u and use the power rule of integration. Adding 3/3 to this exponent gives us 7/3. And then we divide by the new exponent. But dividing by 7/3 is the same as multiplying by 3/7. Bring down the negative 10. Adding 3/3 to 1/3 is 4/3. Then we divide by 4/3, but that's the same as multiplying by 3/4. And don't forget your plus c. I got this final answer by substituting t plus 10 back in for u. Also, 10 times 3 over 4 is 30 over 4, which reduces to 15 over 2. Number 58 is a definite integral because it has the limits of integration from 0 to 1. There are two different ways to solve a definite integral, and I'm going to show you both methods on this problem. Method 1 is to temporarily take away the limits of integration and bring them back at the very end of the problem. So let's go ahead and do the u-substitution. Let's let u equal the stuff under the radical. So u equals 1 minus x squared. That means u prime will equal negative 2x. Doing the substitution gives us this, but instead of dx, we write du over u prime. So du over negative 2x. Then we notice that the x in the denominator cancels out the x that is already there. On the next step, we will take the negative 2 from the denominator and put it out in the front. Specifically, the negative 2 from the denominator becomes a negative 1/2 in the front. And let's write u to the 1/2 power instead of the square root of u. I really need to emphasize one thing. To use method 1, you must take away the limits of integration before you do the u substitution. If you put your 1 and 0 here while you have a u inside, you're going to lose points even if you end up getting the right answer. The reason why is because these are x values. So x equals 1, x equals 0. But now we have changed from x's to u's. You can't mix x values with u. This is an invalid notation, so you will lose points. Anyways, we can find the antiderivative using the power rule of integration. I'm putting parentheses instead of a u because I'm leaving space to put 1 minus x squared back in for u in a moment. So increasing this exponent by 1 gives us 3 over 2 power. Then we need to divide by this new exponent, but dividing by 3 over 2 is the same as multiplying by 2 over 3. A couple things will happen. Let's put 1 minus x squared in for u. And these 2's will cancel each other out. So on the next step, we will have negative 1/3 sitting here in the front. Now we can bring back the limits of integration, because now we are back to x's, so we can use these x values. For a definite integral, at this point you put a vertical line and apply the limits of integration right here. This means we need to find the value at 1 minus the value at 0. So here is the value at 1 minus the value at 0. But 1 squared is 1, so we have 1 minus 1, which is 0. So this entire term is going to be gone. Then we have minus a negative, so this will become a positive. So we will end up with a 1/3 here. And of course, 0 squared is 0, so we just have 1 to the 3/2 power. So that's just 1. So really it's just 1/3 times 1, which is simply 1/3. So this is the final answer, and that was method 1. Now let's do it again with method 2. For method 2, we will change the limits of integration when we do the u-substitution. I usually use method 1 because that's the method with which I am more comfortable. However, you have to know method 2 as well, because there are ways of asking the question that will force you to use method 2. For example, they can set up the problem with the u-substitution already done and then ask you what the new limits of integration will be. We begin the same. Let's let u equal 1 minus x squared. That means u prime will equal negative 2x. Let's do that substitution. As before, we do the substitution and we get this, and we put du over u prime, and we notice that the x's cancel out, so on the next step we will have a negative 1/2 in the front. But here's the difference. Instead of leaving off the limits of integration, we need to change these limits of integration. I mentioned that the 1 and the 0 are values of x. We need to change them to values of u. Luckily, we have this nice formula for finding values of u given a value of x. So, in this case, u will equal 1 minus x squared. That's 1 minus 1 squared, because x is 1. 1 minus 1 squared is 1 minus 1, which is 0. So, u is 0. Similarly, the lower limit of integration starts off as x equals 0. We need to convert this to a value of u. Again, u is equal to 1 minus x squared. So that's 1 minus 0 squared, which is 1. So the lower limit of integration has a u value of 1. Let's write u to the 1/2 power instead of the square root of u. So now we have this. Let's bring down the negative 1/2 and find the antiderivative of u to the 1/2 power. Using the power rule of integration, we increase this exponent by 1 and get u to the 3/2 power. Then we divide by the new exponent, which is the same as multiplying by 2/3. All of this is the same as what happened before. One neat thing about changing the limits of integration to values of u is that we never have to go back to x. We never have to substitute 1 minus x squared back in for u. We can just apply the limits of integration, which means that we need to find the value at 0 minus the value of 1, straight from this. I am going to cancel out these 2's and have a negative 1/3. So here is the value at 0 minus the value at 1. 0 to the 3/2 power times negative 1/3 is 0, so this term is gone. Minus a negative is a positive, so we have a positive 1/3. And then 1 raised to the 3/2 power is just 1, which we don't need to write down. So 1/3 is the final answer, and of course, this is the same answer we got from method 1. Number 64. Use the differential equation to find an equation of the function whose graph passes through the given point. So we are given the derivative of a function, and they want us to find the function itself. So we need to take the integral of both sides of this equation. Of course, the antiderivative of dy dx is just y, which is what we want. So now we need to find the integral of this side of the equation. For a brief moment, we have this, but let's move the negative 48 out to the front, and let's rewrite 1 over 3x plus 5 to the 3rd power as 3x plus 5 to the negative 3 power. We can find this antiderivative with a mental u-substitution. You don't even need to write this green part down. In your mind, think u is 3x plus 5, which means that u prime is 3. The fact that u prime is a constant is a big hint that you could probably do this mentally, because we always end up dividing by u prime. So we will end up dividing by 3, and negative 48 divided by 3 is negative 16. Other than that, we can just take the antiderivative of u to the negative 3 power. So here's my u. I need to increase this exponent by 1, so that's going to be negative 2. Then we need to divide by this new exponent, so I need to divide by negative 2. So now we have this, and of course negative 16 divided by negative 2 is positive 8. This is the general solution to the differential equation, but we need to find the particular solution that goes through the point negative 1, 3. In other words, we need to find the value of c when x is negative 1 and y is 3. So if you plug in negative 1 for x, you should get 3 for y. So here I plugged in negative 1 for x, which is why I'm getting a negative 3 here, and I'm putting 3 in for y. Negative 3 plus 5 is 2. But 2 to the negative 2 power is 1 over 2 squared, which is 1 over 4. So we will have 8 over 4 plus c is equal to 3. Obviously, this is 2 plus c is equal to 3, and subtracting 2 from both sides gives us c is equal to 1. Substituting 1 in for c gives us the final answer. You could also write your answer like this. For this last problem, we need to find the area of the shaded region. The area under the curve from negative 2 to positive 6 is just the definite integral of the function from negative 2 to positive 6. If we let u equal x plus 2, then u prime is equal to 1, which is a little concerning because it will not cancel out the x squared. So we're going to have to use that extra step to fix that problem in a little while. If we do the substitution, we get this, but instead of dx we write du over u prime, but u prime is 1, so that's nothing. So we have this. Notice that because I am putting in a u, I am not going to include the limits of integration. I must leave those off, unless I want to change the 6 and the negative 2 from values of x to values of u. But for now, I'm just going to leave them off. Next, we need to deal with the fact that we have this x squared that did not get canceled out. Let's rewrite this simple expression and solve for x. Subtracting 2 from both sides, we get x is equal to u minus 2. So let's replace x with u minus 2. So now we have this. To get rid of these parentheses, we need to multiply the binomial times the binomial. We get this trinomial. Now instead of the cube root of u, let's write u to the 1/3 power. The next step is to distribute u to the 1/3 power. When we do this, we will have to add the exponents each time. 2 is like 6 over 3. 6/3 plus 1/3 is 7/3. And then we have minus 4u. This is u to the 3 over 3. Plus 1 over 3 is 4 over 3. And then 4 times u to the 1/3 is just 4u to the 1/3. Now we can use the power rule of integration to integrate term by term. Adding 3 over 3 to this exponent gives us 10 over 3. But then we need to divide by the new exponent. Dividing by 10 over 3 is the same as multiplying by 3 over 10. Now, adding 3 over 3 to 4 over 3 gives us 7 over 3. We already have a 4 sitting there. Then we need to divide by 7 over 3. But that's the same as multiplying by 3 over 7. There's another 4. Adding 3 over 3 to 1 over 3 gives us 4 over 3. Then we need to divide by 4 over 3 by multiplying by 3 over 4. Don't forget that u is x plus 2. Putting x plus 2 back in for u gives us this. But this is a definite integral. So let's apply the limits of integration from negative 2 to 6. This means we need to find the value at 6 minus the value at negative 2. 6 plus 2 is 8. So this is the value at 6. Negative 2 plus 2 is 0. Each term has a 0, so this is the value at negative 2. When you have a fractional exponent, it is in the form power over root. So this 3 means we are doing the cube root of 8 to the 10th power, the cube root of 8 to the 7th power, and so on. But the cube root of 8 is 2. So all of these 8s will become 2s. And this feels like a good place to stop. So this is the final answer. You also could have stopped right here.